Malcolm. Let's take it away.
All right. Thank you. I'm going to try really hard not to wander away from the podium because this lapel mic apparently doesn't go to these speakers. But just start throwing things at me if I start wandering that way to point things. So that's what I like to do. I will talk about coronavirus, not in this talk, at the bar maybe. But you have to have gotten your influenza vaccine if you want to talk to me about it, because that's much, much, much more important, okay? Okay, and you have to wash your hands before you come up to me, so just those two things. Those are just my usual stipulations for talking to me. That's got nothing to do with the coronavirus. So tonight I want to talk about something that I've been thinking about for a while, which is, we all know the role that R packages play in our day-to-day lives in terms of data analysis. We load dplyt or ggplot, makes our lives a lot easier. Bless CRAN, there's, how many now? 16,000, 17,000 packages on CRAN? It's crazy. Sometimes I think that there is this divide because R is a programming language both for data analysis and also it's a full-blown programming language. You can do software engineering with it. I sometimes feel that there's this a little bit of a divide, quiet divide, where people are using R in their day-to-day lives. They're using it every day at their work, but they feel like that space between writing R code for their analysis and writing R code as a package is quite vast. And I have been thinking a lot lately about how that should not be the case, in large part because the tools have gotten so good for R package development that they're very, very intuitive now, and it's much, much easier to pick this stuff up. So at the RStudio conference this year, I was giving a workshop with who was my supervisor at RStudio, Rich Ianin, a workshop called My Organization's First R Package. And this workshop, the idea behind it was that we were going to teach people how to make R packages to use in their work. So packages for their inside their company, for their research team, that sort of thing. Code that they're using all the time, plot themes, connecting to their databases, this sort of thing. So rather than thinking about something that I might ship off to CRAN that millions of people are going to download or whatever, no, it's just for our local team. So it was there that I started thinking about really that the tools have gotten so good for this, and the R package structure is so useful that this should really be a part of our everyday toolkit, R packages. And there was a talk that happened there by someone named Emily Reederer, who's fantastic. She had a series of blog posts by the same name as her talk, which was R Markdown-driven development. And she's got this great blog post that's linked in the slides here about how we can take an R Markdown file and slowly transition it into a better workflow. She's very interested in workflows. And towards the end of this transition, you sort of realize, wait a minute, this is actually an R package. And so she posited that while we had been cramming all of our R code just into this single document, into an R Markdown document, it actually works really, really well as an R package. And when I was listening, I had read her materials about this, and when I was listening to her speak, at one point she said about coding projects that there is actually as she put it, a latent R package in your project. So it's already there. It just hasn't manifested itself as an R package. And so these two things clicked for me at once when I heard that. And I thought of this quote from a poem in the Zen literature. It's from a poem called the Sandokai, the identity of relative and absolute. It says, if you do not see the way, you do not see it even as you walk on it. In Zen, there's this belief that in Buddhism, you're striving for enlightenment, right? That's kind of the end goal of Buddhism, so to speak. And in Zen and several other schools, there's a belief that actually you're already enlightened. You are already perfect and complete as you are, and you just don't realize it. And so much of the effort of Zen is coming to realize that you are already there. And so in my mind, these two ideas linked, that when you're working on your project, you are actually working on an R package, and you just don't realize it yet. So the point of today's talk is to try and convince you that your project is already an R package, and that you are already an R package developer and have the skills to dive right in this evening after the bar if you want, because you already have been working on the skills that you need to do this. You are already walking the path of the developer, so to speak. So, the first thing, has anybody ever seen these images before in the background of my slides here? It's got a guy searching here. No? Interesting. They're called the ox herding pictures, if anybody's interested. You should look them up. They're very interesting. So each part of this is going to talk about something that you're doing in your project already and how it directly connects to what you might be doing if you were working on an R package. And in fact, you are. So my first point is that you're already structuring your project, right? So we all have our different ways of doing this. Maybe yours doesn't look like this. But I often set up data analysis projects like this, where I have a folder for my data. I have a folder for reports. This is where I put my R Markdown documents, that kind of thing. Sometimes I have a figures folder. Sometimes I kind of let R Markdown handle those details. Often I have a scripts folder. That's where I'll put my functions, I'll load my packages, that sort of thing. And then, I love RStudio, so I always have everything as an RStudio project. So there's always an RProj file in there for me. So the scripts folder in R package speak might be what in an R package is the R folder. And this is where your R functions go. So when you load ggplot, they're pulling these functions out of the scripts that are in this R folder. So this is sort of a natural place to be thinking about, you have these scripts that you've developed, to be putting them into a setting that R knows how to work with as a package. Although actually some people who use this approach, they put functions in the R folder, and then they also have a scripts folder that this is something that they would be running when they want to compile all of their reports and stuff or whatever. The R package structure already has a folder for data, so this is pretty easy of a match. Reports can be a wide variety of things, but there is a convenient type of object in R packages that I'm sure most of you have used already, which is the vignette. So most vignettes these days, not all of them of course, but most vignettes these days are just R Markdown files. And you can go to the GitHubs of your favorite packages and look in this vignettes folder, and you'll see an R Markdown document that has the same thing that when you wanted to learn about that package that you went and looked up. So this is a very sensible place to transition to reports. R packages also have a few other items that you don't normally see in a project. We have something for documentation, although I'll argue a little bit later that you're already documenting your code. This just makes it explicit. It just puts it in its proper home. I'll also try and convince you that you're already writing tests, and you're just not putting them in the test folder and running them automatically, which is making your life harder. And then usually you'll see a description file and a namespace file as well. So one of my favorite packages, this is a little bit small, one of my favorite packages is the usethis package. Has anybody ever used usethis? Okay. How about DevTools? Yeah, pretty good. Who's made an R package? Okay, pretty good. So usethis is a newer package. It's not brand new, but it's a newer package in the DevTools ecosystem that broke out a lot of the functions that DevTools, Hadley Wickham's package for developing R packages, into a more focused amount of functionality. And so this has quickly become one of my favorite packages to use. So it's got this function create package, and then it gives you a lot of information about what it's doing. So if you're starting scratch, you might want to think about it this way, where you'll use this create package folder. And then one of the things that it's doing is creating this description file. So the description file at face value is kind of boring. It's metadata. It tells you a little bit about what's going on in the package, what does it do, who developed it. This is just how it comes by default. Usethis knows who I am, so it put my name in there correctly. But outside of that, it doesn't know what my package is supposed to do or anything like that. So this is pretty boring at face value. But I actually think that I've come to think that this is the most interesting file in the entire R package structure. And this is actually your golden ticket to the R package ecosystem. And one of the big reasons that I think it's even worth thinking about that you might make this transition from project to package is because when you create things as a package, you get to tap into the ecosystem out there that helps you make code that is robust. It works. You can run tests. You get free access to things like Package Down, which creates websites for packages and that sort of thing, and a whole host of other automated tools that make your life easier. So having a description file is what gets you there. So usethis also has this function, create project, and it has a function called use description. So create project is if you're in RStudio and you kind of go through the pull-down menu and you go new RStudio project. I'm assuming everybody is using RStudio projects, which isn't necessarily a fair assumption. You should really think about it if you're not. Yes?
There's a bug in usethis that it does not, it only works in RStudio. There's some function that only works in RStudio.
Which function?
I couldn't submit it because the submission process requires using proprietary software. So my friend submitted it. It's on the usethis issue tracker, and it mentions my name. So it seems like there's one person who doesn't use RStudio.
Oh, yes. Yes. Well, and that's right. And I actually said RStudio projects, but it's even more fair is not everybody uses RStudio, including some people at RStudio don't use the IDE. Which is true. I don't know. But projects are nice because they solve a whole host of workflow problems for you. So I really recommend using RStudio projects if you're not. But assuming that you are, it's also got this function create project and this function use description. So use description is really cool because if you go to a project that is already active that you already have going and you use description, they all start with use underscore something, by the way. If you use description, it will create this description file for you and put it into your project. And so when I do that, it knows now that it thinks that this is a package because this is the most basic file that I need to tap into the infrastructure that RStudio and other places provide you for working with packages. So description files are really great, and I'll give you a few examples as we go along why that's the case. So you already structure your package, your project as a package, even if you don't realize it. You already write R code, of course. Otherwise, you'd be at like the SAS meetup or something like that. But you're not. You're here. So you already write.
No one wants to go.
You know, SAS has a really big grasp on epidemiologists, so I have to be very polite about SAS in general because I'll hurt friendships. Okay, so so you're already writing R code, right? You know, you've got code that maybe looks like this. I'm grouping iris by species, and then I'm trying to get the mean sepal length. I just learned that was pronounced sepal, by the way. In my head, I always pronounced it sepal, which apparently is not correct. That's what I get for learning about flowers through R. Right? So we have code and we run it interactively at the console. Maybe we use the source function to run a bunch of code at once. So a lot of the things that I'm going to suggest from here on out, I'm going to take something that you're doing already in a project And I'm going to show you what kind of shift that you need to make to think about it in terms of an R package. So the first shift that you need to think about when you're doing these sorts of things is that it needs to be, as I said, in a file called R. Right? That's where R packages find functions that it exports. So usethis has a little helper function. It's called useR. It's a very simple function. It just creates a file for you and it opens it up, puts it in the right place and opens it up for you. Right? So I created a new R file called summarize data, and it told me, all right, I'm going to open this up, and I want you to modify summarize-data.r. The next shift that you have to think, and you may already think in these terms, which is great, is writing your code as functions. So R packages provide you functions, right? And so if you're going to be thinking about changing your project to a package, you need to be thinking about refactoring code that looks like this, where you just have line, line, line that's running in the console or with source, into something like this that's wrapped in a function. Okay? And the nice thing about analysis projects as functions is often you can just do a little wrapper around it. So you don't have to be like writing Hadley level APIs, complex stuff like this. You know, he's so interested in like the philosophy of the APIs that he designs, and like you don't have to think about that kind of stuff at all. Like you can just wrap it in the function and you'll be good. Right? So that's the first shift that you need to think about. The second shift is that you won't be running that function code in the console either. So you may have a project that has a function in it, and then you run it in the console, and then that function's available to you. In an R package, what you need to do is use the DevTools package. DevTools has a couple of functions for this, actually. One that's really neat is load all. And it's loading this package for me, and then it gives me access to this function that I just created in summarize-data.r. So now, rather than sourcing it or rather than running it in the console, I use load all. There's also a keyboard shortcut in RStudio, Command-Shift-L if you're on a Mac, Control if you're on Windows. And then there's also a function called build, which actually, this sort of like, it sort of simulates building an R package and loading everything into your local environment. There's also a function called build that will actually build everything, and the R package will be installed on your machine as such. OK, so this is one that maybe you don't think about, but you already declare your dependencies, which is a really, really important thing in R packages. So you know how you share code or somebody sends you code? Usually it's somebody sending you code. And you try and run it, and it just sort of doesn't work. And they're like, well, it works on my machine, right? But more or less, when you install something from CRAN, or even if you install something from GitHub that's an R package, when you load that R package, the functions in it just sort of work, right? Every once in a while, you bump into an issue where, I don't know, they didn't declare things right, or your system is really wonky and something went wrong. But by and large, when you download a package, it just works, right? You don't have to think about, do I have all of these other packages that help me do that? So whether you realize it or not, you're already doing this to some degree by loading packages in the first place. So if I've got a script here that's running a function called plot iris, I need dplyr for this, because this is calling some dplyr code. And I also need ggplot too. So up at the top here, I've got library dplyr and library ggplot2. And these are my dependencies. If you don't have these on your computer, this function is not going to work, right? You need to do this. And recently, RStudio added something that's pretty nice where it will actually look at the script you have open, and it will figure out if you have those packages installed, and will offer to install it for you, which is like a mind-blowing feature. It's so great. So that's made my life a lot less painful, getting code that way. Sometimes even my own old code, where I'm like, I just have not reinstalled the package or whatever, and I'm like, what idiot designed this? And it's me. So the shift that you need to make when thinking about using packages that are from somewhere else when you're creating a package is that you have to declare them formally as dependencies. So usethis has a function called usePackage. It's very simple. usePackage, quote unquote, dplyr. So here's the thing about these usethis functions. So we've got back here useR, and we've got usePackage here. when I was sort of like informally declaring my dependencies up here by using library, this was in my code, right? This is what I sent to my colleague or whatever, and it was right there. This usethis code is actually kind of ephemeral. It disappears when it's gone. You just type it into your console. It gives you some information about it, but you're not actually saving it anywhere. So sometimes what I see is when people first learn use package, they'll actually put this in their R folder in their R script, use package dplyr or something like that. But you actually don't need to do that. You just need to run it once. Because what it's doing is it's adding it to that description file. It says I'm adding dplyr and ggplot to the imports section. Right? So the third shift that you have to make when you're using packages from somewhere else is, unfortunately, you don't get any more free lunch with not having to write the name of the package before the function. When you do library package name, you don't have to write group by or summarize or ggplot or any of those things. But since I'm not actually attaching the package when I'm using it in this package environment, I need to type out the name in full. So group by's real name is dplyr : group by. It just has a short name that it goes by, which is group by. That if you're familiar with it, you can load dplyr, you can call it that name, and it's fine with that. This is a slightly more formal setting, and so you have to call it by its full name. You have to be respectful. Also to find it, because R won't know where to find it if it's not there. So you have to use dplyr : group by function or package name : function name. So if you crack open an R package and you look at the code, almost always it will look like this, where it will have a mix of internal functions, base R functions that don't have the : operator there, and then functions from other packages that it's using this with. And there's a few tricks that you can use not to do this, but by and large, this is the best practice for it. So what happens to that description file is that when I use package, it adds imports ggplot2 and dplyr down here, right? So in some sense, I'm just I'm moving this over. If somebody wants to look at my description file and find out what packages they need to use my package, they can look at this. Luckily, the R package system takes care of this kind of stuff for us, which is amazing. When you install something fresh on your computer, you install ggplot2 fresh on your computer, it installs everything else that you need, right? You just have to type the one line install ggplot2, install the packages ggplot2, and then it gives you all this other stuff that it's going to be installing in the meantime. And that's because it's looking at the description file and it's figuring out what does it need to actually run this package. So that's fine if you have a package that's on CRAN, but you're probably not going to take your analysis project and ship it off to CRAN because first of all, they probably don't want it. They're busy, so don't do that. And second of all, you probably don't want to do that either. But you may be putting it on GitHub. Or locally, what you can do is DevTools has this function called install_deps. And install deps will look at a project. It will look for a description file, and it will install anything that you need to make this project run, which is incredibly, incredibly convenient, right? If you can ship your project off to your colleague who's new to R, doesn't know what to do, and you say, well, just run this line of code, and then you'll have every package that you need to run this. Because you can also stipulate here and through usethis other details about the R packages that you need. Version numbers, maybe the package lives on GitHub or GitLab or somewhere else. You can tell DevTools and R where to find those things, and it will install it for whoever wants to install these things. So this is really convenient. Sometimes even on my own projects, I'll run this because I'm very frequently kind of starting from scratch on things. So these two things, the first two things, writing code and declaring your dependencies, it probably didn't take you very long to be like, yeah, right, of course. How else would you run R code? This one might take a little bit of convincing, which is that you already test your code, right? So who's used the test that package? Yeah. Any other? There's a few other testing suites in R. Anybody use anything else? Yeah, it's like a tiny test. think Eway has one, like his own version, that's just like a kind of minimal version of a testing suite. So testthat is Hadley's package for writing unit tests in R, which is meant to kind of kick the tires of your R code and make sure that it functions well. So when I first started developing R packages, this was the thing that I was like, oh God, I don't understand this at all. Like, I don't know what kind of tests I'm supposed to be writing. This seems like very like heady software engineering stuff. I don't really know what I'm supposed to be doing. And so I always put it off until like the absolute last minute, which just made it worse because spending like 2 days writing tests is not a good way to spend 2 days. The thing is that you are actually writing tests all the time for your code. It's just that you're not doing it formally. So here I've got this function clean data, and I'm just trying it out on Iris here. And like, OK, something went wrong. And I usually make that face when I'm doing it. And then this kind of seems like it works, except I gave it Iris, and it actually gave me empty cars back, which is not what it's supposed to be doing. Right? And so usually what I would do is I would fiddle at the console. Right? Like I would kind of iterate between, like, I go back to my code, I tweak a few things, reload my function, and then I go in, I fiddle around at the console again. This is a test. Right? So Hadley, in his R packages book, says something to the effect of, you're always testing your code. You're just not writing it down. Right? So this is a formal mechanism for doing this. The problem with this is I might fix this. Right? This is usually what happens. I figure it out. I'm like, oh, yeah, I got it. It's great. First of all, it will usually break later because I did something and I didn't save it or whatever, so it breaks again. Or I bump into something else much later down the line, and I start fiddling with that at the console. I'm writing kind of these sort of informal fake tests. And I fix that bug, but I don't realize that in the process, I broke this bug. Because I never wrote this test down, I don't know that, right? So usethis comes with a whole suite of tools to help you with this. The simplest one is usethis, which will, I call this clean data. It will add testthat to your package. It will open the file for you and do a bunch of other stuff that you need it to do to run these tests. Right? And then DevTools has this function called test. Let this roll around a second here. Right, so it's opening this stuff up. And then DevTools will run a test of this and give me a report of what's going on. So once I fix that test and I figure out what's wrong, I can encode what I was secretly doing, which was I was running my function, and I had an expectation of what that function should give me. Right? And that's the language of testthat, is that you can write formal expectations of what your code should give you. And this is extremely, extremely useful in data analysis projects because data changes. Data changes, the packages that you're using change, all sorts of things can go wrong, right? You accidentally didn't save a part of a script, or you changed one part and didn't change another, something goes wrong, and you don't realize that your whole report is broken now, right? So testing is still important in data analysis, which is why you're already doing it at the console. Okay. So this is not just an excuse for me to get a drink of water. I wanted to take a moment here. I have more to say on this subject, but I wanted to take a moment here because I think these ideas here give you the most bang for your buck in thinking about project as package. So the first big idea is to use a description file, right? This is your golden ticket to the R package ecosystem. You can start using the usethis functions, the devtool functions, and loads of other neat tricks for making your package better. And it can also help you formally declare the dependencies that you have on your project so that people can more easily run them by installing them quickly. Right? The second big idea here is to write code as functions. And this is not new. There's lots of paradigms that suggest that you should be doing this in your analysis code. Does anybody use Drake, the Drake package? Oh, need to get a Drake talk in here. Drake is awesome. I have a link to it at the end. And that's a big idea. It's a workflow package. It's very, very nice. And it's centered around the idea that you should be writing your analysis code as functions. It also does a remarkably good job caching your code so that you don't have to keep rerunning things that you don't need to rerun. So highly recommend looking into it. And it connects with this idea of a project as a package really well. And then the other big idea is that these things that you're doing at the council, you should write them down as formal tests, right? You know how your function should be acting. You have expectations about how it should be returning things to you. Write them down and automate them. It's a little bit of effort in the moment, but it makes your life a lot easier in the long term because you can track them more easily. And you're already doing it at the council anyway, so you might as well put it into a formal system. Okay, so this is a basic R package, and this is a quote that I really like from Suzuki Roshi, who is a Japanese Zen teacher who came to the United States and founded many places in the San Francisco area, Bay Area. And this is one of my favorites. Each of you is perfect the way you are, and you could use a little improvement. And this has actually already been adapted to RSpeak by Hadley. Each package is perfect the way it is, right? And it could use a little improvement, right? So these ideas here are sort of like the most basic things that you can do to explore this idea of having a project as package, or even creating a package, creating a legitimate R package that is meant to operate as they normally do. For instance, if you want a personal package, or if you want to develop something for your team, or if you want to submit something to CRAN, right? These tools, I only had 3 or 4 lines of code from usethis and DevTools. These tools have gotten extremely easy to take on, and they're very communicative. They tell you exactly what you need to be doing so you don't get lost, and it handles a lot of that tedious detail about setting up R packages. First, so that you can access the power of the R package, and second, so you can focus on your main task of writing code. Right? So the point here is that don't worry too much if you feel like, okay, but this is no ggplot 2, right? Like this is just some package that I have because I kept writing the same plot all the time and I wanted a function for it. The best code is code that works, right? So you don't have to be Hadley level just yet, although you already are. You just don't know it. All right. So a few quick points about the rest of this, because I just want to point out the fact that a lot of the things that you're familiar with R packages extend very neatly to connecting it to an analysis project. And the first is documenting your code, right? This is maybe you don't do this. We're told that we should do this right away, right? You should comment your code. You should write function names that are like, it tells you what it does, I've gotten a little bit better at this over the years, and I'm still, when I'm writing code in this format where I'm running it in a script or at the console, I've gotten better if I know someone else is going to be reading it and there's a little bit of peer pressure. But this is fundamentally documenting your code, right? Both giving it comments and giving descriptive names, right? Giving your variables descriptive names, giving your functions descriptive names. This is documenting your code. And lo and behold, R packages have a system that you're already familiar with because you've already looked at help pages for functions in packages that you've downloaded from CRAN that formally document code. And this uses Roxygen. So I'm using Roxygen, use Roxygen MD, which lets me write Roxygen using a markdown format, which is nice. And my code ends up looking a little bit something like this instead, where I still have comments here, but I have these apostrophes after my comments. And then I have these things with the @ symbol in front of it that are called Roxygen tags. And I'm not going to go into the nitty-gritty about what these things do, but it lets you write your comments in such a way that will map automatically to the help pages that functions that you normally see produce. And so when I run document, which is a DevTools function, it will do a few things in the package that it needs to, and it will also write this help page for me. So now if I do $plot iris, a help page for this has been produced in just a few lines. So this I know you do, because this is like 80–90% of the job, right? If only we knew how much time we'd be spending cleaning data. So you already clean your data, right? And you've already used data in the context of our packages. I've had all these examples from Iris. from MT cars. ggplot2 has MPG. One of them has some Star Wars data. I don't know if it's ggplot or dplyr. But the point being that R packages have a formal system for exporting data. And this is really nice when you have a sort of a steady state data. Data is often changing, and so this won't work for every situation. But if you just need to clean data once and then have access to it to be able to run a bunch of reports on and that sort of thing, this is a really great system for it. Usethis provides a way of actually putting your data cleaning script somewhere in your R package called useDataRaw. Right? So it creates this space for me, and then it will actually open up a file that I can put my script that I use to clean my data in. So my script looks like this. I like this function a lot, clean names from janitor. Makes names way better. I'm also taking away some factors, and I'm turning things into a tibble. And then usethis also has a function called useData. And this is what actually exports the data. Right? So iris2 is a data set that I want to work with because I love flowers. And so I want to be generating lots and lots of reports about them. And so now when I load my package, iris2 is going to be immediately available in this format. Right? So this is also useful for things, it may not be useful if, for instance, you have to connect to a database to get your data, something that's changing every day or every hour or every minute. But it may be useful for storing, for instance, data dictionaries for your work, testing data for quickly testing functions without having to connect to your database and that kind of thing, and quite a bit more. So you definitely already write reports in some capacity. It's just a matter of if you're using my favorite tools for it, right? So my favorite tool for it is, of course, R Markdown. And as I mentioned, R packages already have an excellent system for producing R Markdown reports, which are vignettes. So this is the most basic way. This doesn't work for everything, but if you have a report that pretty much stays steady, that you just need to re-render every once in a while, vignettes are really nice because there's already a formal way of putting them into the package and then building them over and over again. And then you can easily call the functions that you wrote in your R folder inside of that vignette. You'll also see people putting it into a folder called inst. Inst stands for installed files. And this is like your the hidden space in the trunk of your car where you can kind of sneak whatever the heck you want into your R package. The top level of the R package is kind of strict, right? You have certain things that you're supposed to put in there and certain things that you're not supposed to put in there. Inst, you can pretty much put whatever you want in, and it will build it and it will install those files. And in fact, that's what inst stands for, is installed files. So sometimes what you'll see people do is they'll put reports into a folder in here. So I'm creating a directory with the fs package called reports. And when I build my package, that report is available inside of the package. So if somebody else installs it from GitHub or I'm sharing the installation file with someone, that report's available to them. And then finally, even though I said that the top level of R packages can be pretty strict, I can create something at the top level and then use a function called useBuildIgnore, because R packages have a mechanism of letting you say, OK, just when you're building the R package, don't worry about this folder, don't worry about this function. All right, this is a bunch of analysis stuff. You don't need to know it when you're actually building the package, but you would maybe have it in your repository. And so earlier when I mentioned that some people will have an R folder and a scripts folder, they do something like this with the scripts folder, because the scripts folder is not a valid R package folder at the top level, whereas R is. So you need to build ignore it. But you have a lot of options here, right? So it kind of depends on the needs of your reports. Very often, I'm a scientist, so very often I just have to write one paper and then that's it. I might have to make some changes to it, but it's not a report that's changing for me every day. So the vignette structure makes a lot of sense for me in a lot of cases. But if you need more flexibility, really it's your choice how you go about that. So finally, you already share your code, and it's terrible, right? I hate getting R code from other people because I get a script, and it just doesn't run. It never runs. I don't know if I've ever gotten some R code from somebody else that ran right away. Something about my system is different than your system. And R packages are meant to solve that problem. That's the biggest problem that they solve. They are the fundamental unit of shareable R code, right? So they're meant to work very easily on somebody else's machine. So, you can put this on Git. Hadley says that regarding this issue of like bringing the pain on yourself as the developer, is that the whole point of this is to make things easier, as easy as possible on your user, which usually means making things harder on yourself. So I do agree that actually submitting to CRAN is a commitment, and I think sometimes people don't think about that. They just want to get it up there, and they're not thinking long term about like, am I actually going to be able to maintain this package? Do I have a plan if I can't? What happens if it breaks next week and I need to fix it right away? But I also think that the infrastructure is such that with GitHub and other tools for sharing packages, that the vast minority of packages should even be thinking about going on CRAN. Because I think that this should be an everyday tool, I think that should be, you have a package, you want to distribute it in this formal way, you're ready to maintain it, and so you go this route of the formal distribution through CRAN, which is very convenient for the user, and not always for the developer, although often it is. Oh, sorry, I haven't been looking left.
I think I saw flash by and it was usethis.
Oh, yes, I didn't actually mention that. So it does exactly what it says it does. Usually these function names are pretty straightforward. Yeah, here. So I didn't run it here because it actually takes a little bit more setup than you have to add Roxygen to it before you can use it, because that's how it exports it. But yes, this is how, if you like the Magritter package, the dplyr pipe, whatever you like to call it, there is a way in usethis to make it very easy to export, which is use pipe. And that will make it such that when you load your package, it will just be available to you. You don't have to load dplyr or Magritter or anything like that. And then you can also use it in your code inside of your package very easily. Thank you.
Thank you so much.
GitHub, there's a function called useGit and useGithub and usethis that makes that process easier. You can install it locally on your machine with install. There's also a keyboard shortcut for this in RStudio. You can also wrap this up as a zip file and ship it off to somebody, and they can install it that way. There's lots of different ways. And actually, if you're interested in, some people have internal packages that have proprietary functions and data in it, and they can't share it with other people. So they have to do it very carefully within their own systems. And so we have some material on that on our workshop on my organization's first R package. So if that's something that is required for your work, where you need to be very careful about what you're sharing, you might want to look into that as well. All right, what time is it? I'll tell you the truncated version of this story. So there's another story that I thought of when I kind of made this connection in my mind that's connected to Buddhism. And briefly, the story goes that there is a child who runs away from home and is gone for many, many years and grows into adulthood. And in this time period, his father becomes very wealthy and moves somewhere else and is in an unrecognizable level of wealth in a new place. Many, many years down the line, this person encounters his father and doesn't recognize him because he hasn't seen him since childhood. The father recognizes him right away, and he tries to give all of this to him. This is yours. This house, all this wealth that I have built up, this is your inheritance. And he runs away because he's like, what the hell's wrong with this guy? He's crazy. He's trying to give me all of this stuff. I don't understand it. So the father instead has some of his people go after him and hire him to start, shoveling manure in the stocks and, just kind of working his way up at a reasonable way. And so he slowly throughout time, the son works his way up through the structure of the household to the point where he ends up managing the household. And in some versions of this story, the father at this point tells him, you are my son. That's why I wanted to give this to you. This is all yours. And he's totally shocked. In another version of the story that I like more, at this point in the story, the son has actually already realized that all of this is his family and his inheritance. And so it's no shock to him at all. So to me, this is what coming home to R packages is like, is that as an R user, you have this inheritance of this package infrastructure, of all of these tools that make your life easier. You have these tools that make it so easy to start developing R packages, and they are yours for the taking. There are a few other helper points for this, a few helper functions and guides that I really like. So one is R Markdown-driven development. This blog post is great. Her talk is great. Go check it out. She's also got a recent addition called, I think she called it a technical appendix that gives you all of the guidance that you need to actually structure your code in this way. Another package that I really like is called RR Tools, as in reproducible research. It's oriented towards academic research, but it's not just suited for that. It works well for other things as well. And if you've heard of the idea of a research compendium, which is an idea in reproducible research, this package tries to enact that. So this will help you create R packages for analyses in a very opinionated manner that is very, very interesting. So it's got a lot of usethis style functions to help you do that. There's also, has anybody used the Golem package? This is a relatively new package that's really, really neat. So there's also this stream of thought going on now that Shiny apps should be R packages as well. And so Golem is an opinionated infrastructure for taking a Shiny app, potentially a very large Shiny app, and turning it into an R package, such that you can run a Shiny app through this structure at the production level. And then I mentioned Drake already. Drake is great. This is a workflow package, and the link here, if you go to my slides, this takes you to how do you use Drake in the context of I'm putting my functions, which Drake wants you to do, into an R package. And so there's a way of thinking about this, and there's those terms as well. So my final request is that you take an invitation to create some sort of package. All right? A personal R package is a great place to start. All right? Maybe you have a ggplot, concoction that you use all the time, and you find yourself copying and pasting that code over and over again. That's a great thing to put into a personal package. Maybe you've got an R Markdown template that you can't remember the YAML for, and so you keep copying and pasting it. That is a great thing for a package too, because you know that we have this structure of creating our Markdown templates and packages, and usethis makes that pretty easy as well. Using it in your work as an internal package is really great. It can be a really great way to standardize work on your team, sharing functions easily, creating an environment that is installing the same packages very easily. Finally, just taking an existing project and adding a description file to it, telling it your dependencies, and using some of these tools, whether it's writing tests or loading functions through this package mechanism, that kind of thing. So I really invite you to try this, because I think that this R packages should be right there with your data management tools, your data visualization tools. You need workflow tools as well, and R packages are great for it. They're very well built for it. And so I think R packages should be a part of our everyday toolkit, and I really invite you to try it out, which may feel a little daunting. This is by Trungpa Rinpoche, who's a Tibetan teacher, who says, the bad news is that you're falling, okay? You're falling through the air, you don't have a parachute, but the good news is there's no ground. Trying out R packages, all right? Hadley's not going to come to your house, Cran's not going to come to your house and being like, are you qualified to do this? Okay? There's no ground. So I really recommend checking out the R packages book. The second edition, Jenny Bryan joined the team for it, who is like the best R communicator in the world, and it's amazing. It's looking really, really good. The first chapter is called The Whole Game, and it works in R package from A to Z. And it's really nice. It's a really nice guide to getting like off the ground right away, using more or less all these tools that I just showed. So this first chapter in particular, but the whole book is great for those details that, of course, I couldn't go into. And that's it. So thanks for coming. I'm on Twitter. If you're on Twitter, find me on Twitter. We're all on Twitter, right? If you're not on Twitter, you got to get on Twitter.
No.
No?
Twitter's a great place for art.
For R. Don't do other stuff on
I'm
Twitter.
I'm not on Twitter for anything else.
No, everything else on Twitter sucks. For R, it's great.
So I'm supposed to lead the QA, but I feel like maybe you can do that, or should I?
I feel competent.
I think you can handle it,
Yeah.
and then I'll come back.
Any Q's or A's?
How did you make these slides?
Yeah. Oh, well, made with string on, also string on themer, string on extra, and then these typey things. That was made with the ASCII cast package, which is on the rlib group on, I don't know if it's on Crayon yet. I think it is on Crayon now, which I heard about this through Jenny Bryan's keynote at our StudioConf. She used this, and I thought it was so cool, and I was like, I got to use this immediately. It was pretty pleasurable to use. I liked it.
So I thought it was pronounced Sharon.
String on.
What?
Well,
Yeah, what's the right?
so, I mean, so I pronounce it Shringan because can anybody provide the answer why I pronounce it that way? Yes, Naruto. Yeah, right. So the name of these slides is a reference to an anime that I love, and I pronounce it the same in the.
But there was like a pronunciation code in the
Oh yeah.
explanation for how to use this package, and I thought it was Sharon. But maybe
Shringan.
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 What do you say?
I say Shringan.
Okay.
That's how they pronounce it in the anime. I don't know. Yue wasn't in the anime though, so maybe he pronounces it differently. I don't know. It's not really that important. It's actually
I just wanted
it's intentionally meant to be hard to pronounce because he didn't want a lot of people using it.
It's awesome. It's catching.
It's really nice is the problem. Yeah. He named it that because he was sick of using Beamer slides because they all looked the same.
Yeah.
And he thought if he made a new package that everybody liked, then everybody would start using it, and then the slides would all look the same again. So he made it hard to pronounce so that people wouldn't talk about it. But they did anyway because it's so good. Yes?
Thank you. Yeah, really good. Could you talk more about how to structure tests? Because I often find myself adding I guess an R stop if not, or just not assert kind of phrases into functions, but
Yeah.
But I want to find better ways of having tests.
Yeah, no, that's that is, I would say, is a good practice, is asserting that arguments, you're saying you have an argument, you expect it that it's a character vector or something like that.
Or even I'll just do stop if not all the columns, sum to, or there's no null from this, or
Oh yeah, that's a test. Yeah, right. Yeah, because there's a little bit of a subtle difference between validation that you might be doing argument checking at the front of a function, and then testing that you're doing to make sure that it's giving the right output. Yeah. So basically, if you want to be testing what it's returning, if you want to be examining what it's returning, that's a good thing for a test. And a good rule of thumb when you're writing tests is, and this is a very soft guideline. I often don't do this, but it's very good. It gets me going a lot. Is that for every R file that you have, also have a corresponding test file. And usethis actually encodes that, because if you have an R file open in an R package, or something with a description file, and you type useR into the console, it will, usetest into the console with no arguments, it will create a test with the same name as the file that you have open, and then open that for you, which is a really convenient way. And so I have found myself doing it more often because it encourages me to do it because it's so easy.
Should you test functions themselves, or just
Should the tests be functions?
where you I guess as it doesn't but the test is just you have some inputs and you just make sure the outputs are the insert parameters that you want.
Yeah, right. So if you're checking inputs, that's something that you might want to put in the package, or in the function, I would say. Generally, you want to be kicking the tires for the user experience. You want to make sure that if it's supposed to error, it is. If it's not supposed to error, it's not. Maybe you do want to make sure that that validator's checking, so you would test, okay, this should produce an error, that I give it something that is supposed to be a character vector, and I give it something else. That should throw an error. And so, again, there's no real strong hard rule of thumb for this, but you want to test things that are not pretty much guarantees. Some things it's like you just don't have any doubt that they're going to work. And you should not test too many internal things, because then if you change those internal things, it becomes a pain because you have to update all your tests. So focus on the user experience of the testing. Try and have a test file for every R function. And some people say that you should shoot for, there's a function in DevTools called test coverage that will give you a report how many lines of code that you're testing. And so, a rule of thumb that you see a lot is 80% of your code should be tested. Although that itself is a pretty soft guideline. Sometimes you don't need to be doing that. Sometimes you need to do more.
What does it mean by for a line of code? That's a function.
Yeah, this is so it's that the line actually gets executed sometime during your testing. Yeah. So it actually calculates every line of code in your R folder, and it checks, does this line of code actually get fired off during this testing moment here? And I have found times where I'm just like, oh, there's a whole part of my function that it's not just not being tested, it actually is never ever going to run, because it's impossible for this logic to fire off and run it. So I can just actually delete this code. Yeah, of course.
There's that output where it's like failed, succeeded, or like there's like
Yeah.
How can you set it up to like kind of have that nice little?
Yeah, you don't have to set anything up. This is the nice thing, is that they've set it up for you. Let's go back here. This one, right? So what's happening here is that I've written a test, and then I'm just running the test function, which is in DevTools. And this output is from DevTools. So if you run test or Command-Shift-T or Control-Shift-T, depending on which operating system you're on, it will give you this nice output. You have to stipulate that. So Tesla has a formal structure of laying out expectations. So if I run this code, I expect that it returns a data frame that looks like this or whatever. And if it doesn't do that, it will error, because it's actually running our functions. And it will error, and then that's the failure. So this is passing because nothing's erroring. Yes, you had yours up for a while.
Well, I just wanted to offer a suggestion.
Oh, sure.
For test, like the best book I think written is Test-Driven Development.
Yeah.
By Ken Keck. By examples, Test-Driven Development by examples.
Yeah, and so test-driven development is this idea that you should actually write the test before your code, and then write your code such that they pass the tests. Which is interesting. There's actually been some research done on it that it seems like it's actually just more important that you just write the dang test. And if it encourages you to do it, it actually doesn't make your code any safer. But in some ways, it does encourage you to write tests, because it's like front and foremost in this.
It helps me iterate for what I want to do.
Yeah,
I
right.
feel like it's a superpower.
Yeah.
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 When I started doing it, I felt like I was 10 times more.
Yeah, absolutely. And that's people who subscribe to this really like it for that reason.
It's all in Python, but that particular book. But you can use it as an example. And I took everything in that book and did it use test this. And
Yeah, it translates perfectly fine, yeah. There's a question back here, I think.
What if you ask more about, is there like a set, so there's a structure for how to submit packages to CRAN? Because the reason why
Yes.
people submit to CRAN is like it's different, like the requirements change.
Yeah. I have to hold my tongue a little here.
The review, it seems like every review is different.
Yes.
Now there's no way
Yes.
to understand what
So,
the requirement is.
right. So it's a little of that and a little bit that there are certain requirements. And use this and DevTools are meant to try and get you most of the way from the most important requirements, so they are taking care of those details for you. There is a document called Writing R Extensions that has all this listed out. It's very, I find it very difficult to find what I need out of it, but that is available, and every once in a while it does you well. Usually the best bet is running R command check, which I didn't really talk about here, but R command check is sort of this golden standard for, is your package in good shape? Running it a lot, often, in many different places. Running it on continuous integration services like Travis and AppBear and GitHub Actions. There's a service called RHub that will run it on a bunch of stuff, including the machines that CRAN has, or tries to get as close as possible. And you just try and get a clean bill of health every time, and that really helps. I have never submitted a package to CRAN successfully on the first attempt. And Hadley talks about in his book that he's had packages rejected plenty of times, and it stings, but he just kind of he makes the changes and he tries it again. And some reviewers are stiffer than others in those regards. Some are extremely helpful. I would say most of the people on the front line are very, very helpful with it. In the new book, the new R packages book, throughout the book, they have a section called CRAN notes or something like that. They give you a lot of details on how each section is related to when you actually go and submit it to CRAN. So you've actually submitted to CRAN, and you've had a lot of back and forth with trying to.
Yeah, it was like a lot of back and forth.
Yeah.
Where I fixed the comments, and I had another comment about something
Yeah,
different.
that's normal.
Keep back in the crowd.
That's normal. Most of the time it's helpful. Most of the time it's good improvements. Yeah, and you should just make the changes and resubmit.
Yeah.
Yeah. Other questions? Yeah.
It's a long-winded question.
Give me the tweet
function-
version.
I don't do Twitter.
280 characters. I'm going to count.
It's proj activate, so it's actually preventing me from doing R Studio projects. And so, could you ask your colleague to? That has to be a question.
Yeah.
Or could you perhaps fix because I don't know how to do reprex.
Yeah.
I made a
Reproducible
test.
example. Yeah.
And I submitted a patch, and the test is in the patch, and it works. Well, I didn't submit it. My friend submitted it because I don't use proprietary software. So if you would look at issue number 954.
Can your friend submit this question to me?
He already did. He said, hello, instead of going through the process of creating a reproducible example, can you just look at this div?
Interesting. Yeah. Well, it is. It is. I'm just joking, by the way, but it is. I would like to see it.
Yeah, I just sent you an email.
I do think that there's something wonky going on with Project Activate. It does some weird things sometimes.
Yeah. Well, I can tell you one weird thing. One weird thing is it assumes that the path it's passed is a absolute path. And I guess this happens because if you call from RStudio, it always passes an absolute path. I don't know. I don't use RStudio, but when I gave it a relative path, it didn't work until I fixed it.
Yeah. Because at the top level, you don't need an absolute path, but it passes around on the inside as one. So when I say top level, I mean using the function, because usually you're not using Project Activate directly. Usually that's usethis.
But somehow I found it, so it must have been at the top level. Yeah?
Oh yeah, you can, because it's an exported function, and there are certainly cases where you would, but
this is like the only time I ever used RStudio project, so I have no idea how. I don't remember any of it.
And actually, usethis has kind of its own way of dealing with things anyway, and so it doesn't technically have to be an RStudio project. But if there's something going on wrong on the inside with that, it sounds like you found a good bug to fix.
Well, I fixed it already.
Yeah.
And I gave a test.
Yeah. But they want a reprex?
Yeah, something like that. I don't know. Actually, another curious thing. Maybe you could. This is actually a real question. Yeah.
This slide there was supposed to be a Q&A.
Yeah. So I asked questions. I think part of the reason I was having trouble running the test is used in the test suite, so that like when I'm modifying if Project Activate doesn't work on my system, then I'm going to have trouble running the test. Is that possible or no?
Well, it doesn't. It's not. DevTools is not calling that function to run the test suite, but usethis does use it to set up test functions.
So if I call DevTools test.
Yeah, it's
if
not call. I don't believe that it's calling that function at all,
Okay.
or any usethis function.
Oh, okay.
I don't think, because that was actually one of the points of developing usethis, was to kind of make this separation between project and package setup, which is a lot of what usethis is doing, and then the build tools that DevTools is taking care of. That's actually building the R package. Yeah.
Okay.
Yeah. That was a Twitter thread, but that's okay.
Oh.
That's okay. Other question? Yeah.
I just want to make a comment about be careful when you get your package on CRAN. And when. Because it does take a lot of commitment
To maintain it, yeah.
maintain it.
Yeah.
You have
I agree.
You have to be ready to be bombarded with questions.
Mm-hmm. Yeah.
Um,
I agree. And
unreasonable demands.
most things are very reasonable that you get. Most things you don't actually need to do because your package can already do it, and they just didn't find it.
I mean from the
and
user.
What's that?
I mean from the user.
Yeah, right. But then every once in a while you get an unreasonable demand.
Right.
Yeah.
Not only that, when you submit updates to packages, well, I can understand from CRAN's standpoint, they don't want you to submit an update every time you change a little thing.
Yeah.
Because it adds work to them.
Mm-hmm.
But because they want the user experience to be better and better and better, so they're putting the onus on the developer to make things more and more stringent.
Yeah. So I have.
So I submitted an update. I haven't updated my package for quite a while. I
Mhm.
submitted a patch update, and I got a note back from the CRAN masters saying
CRAN
that
masters.
there are about a dozen dependent packages that depend on your package that failed on this
Yes.
update.
Right. Yeah. So there's a whole
Have you
system.
contacted these guys?
Yeah, right. So that's actually something as a maintainer you are supposed to do, is if you're updating your package and other packages depend on your package, there's a system of checking those, what are called reverse dependencies, people that depend on your package. So there's a package called revdebcheck that will process all those for you against your new version and make sure that nothing's failing. And I have had this happen to me several times because I have a ggplot based package that I do some weird stuff in, and every once in a while the new ggplot will break it. And so I have to fix those things before it comes out. But the good news is, like, usually if people are non-responsive as a developer, they'll usually, you can just say to CRAN, well, I emailed them this, I gave them such and such amount of time to fix it, and I never heard back, and they'll do it.